So I have up here and also linked on the slides this bouncing ball code. This is last semester what we did towards the end with a bouncing ball to make Pong and perhaps making lots of bouncing balls around the screen. So object-oriented programming really helped us create these like really complicated variables where we had information like x position, y position, and direction, and we also had functionality or behavior of this ball, like how it bounces off the sides and goes a certain way. Um, so what I said last semester was objects are just really complicated variables. Not only do they have data, they also have behaviors or functions tied to them. And as we review, we take a look at this code I have in front of me. Oops, made the ball disappear. So at the very beginning, there's function ball. We decided this is how you use objects. The one keyword was this. So we know this, and then we have this dot operator. This dot x sets this particular ball's x coordinate to x equals 20. And then same with the y, I also had some direction. We gave it a speed. So for example, I increase this, it'll bounce a lot faster. Okay, I change this number, and maybe it starts off in a different position. So far, so good. And then down here, this move function is an example of a member function. So how does a ball move around the screen? It increases the x and increases y according to the speed. In this case, it's 20. You either subtract or go away. What does it mean to bounce? Well, let's go off like the left wall. If it wants to go negative, if the x coordinate is negative, then we change the direction. We have it go right instead of like moving left. And that's same for all the other walls around it. We have to do this 4 times. There are 4 different directions, 4 different walls that causes this behavior. Perhaps we'll start with just one direction at first and then move on and try to add more of this bouncing behavior. And just to remind you, this bouncing ball is rather simple. It bounces always in a clockwise direction. I hope you noticed that here. It doesn't like bounce left to right and then go counterclockwise occasionally. It's always counterclockwise for the most part. And show is another example of a member function. This displays the ball to the screen. Okay, so that all those parts make up the ball definition. This is what it means to be a ball. It can move, it can bounce, it shows itself, and it has some data that's tied to it. And from last semester, the simplicity, after you've done all that work in defining it, you benefit from like using your object that you created. Notice how simple this code is down here in the draw function. We give our ball a name, we called it Bob. Bob moves, then bounces, and lastly draws itself to the screen. And somewhere in here we made a variable, we declared it, var Bob. Okay? So we remember some bits of this, and now we'll switch over to Python. So I have a trinket over here. You're welcome to fork it so that we can create a bouncing ball in Python, and ultimately this is in service of our assignment 10, which generates a random skyline with different buildings. So if I press this is my example of the city skyline project. You hold down the mouse and it generates a random scene. Sometimes it looks good, sometimes not so much. There's stars and randomly generated buildings. I'm clicking the mouse to regenerate a new city skyline. And you have free reign on your kinds of skylines. It doesn't have to be just square rectangles and things. But there are some minimal requirements, like randomly generated heights of buildings, along with positions of windows. And some stars in the background, you're welcome to add any things in the scenery. So each time I click, it generates a new one. As long as you generate some new one of some sort, you've achieved the objective in doing object-oriented programming for a simple building class. All right, so that's my city skyline. Now we go to the bouncing ball. So in my trinket, I hope to leave you with that same example we did last semester in JavaScript. Let's see, make this text go bigger, okay? So in object-oriented programming in Python, it looks a little different. In my starter code, I have like class ball in the assignment. There's something about init. There's show, and then there's setup and draw. So the building, or in our case a ball, this part is the function definition, or object definition. This is what makes a ball. So this part defines what it means to be a ball object. And then the other parts that are important, def over here, notice the underscores, underscore, underscore init, underscore, underscore self. This is called the constructor. Self is very similar to this from JavaScript. So in this case, I just have a print init here to make the compiler happy. But here you do self.x, let's say, because a bouncing ball has an x and y coordinate, and we'll maybe start it in the middle, self.y. You start also in the middle. Before we had a direction. Let's have our ball have a speed of 20, self right as direction, false. Is it capital? Yeah. Self dot left equals true. Self dot up equals, let's have it go up and right. True. Self dot down equals false. Okay. So these are 1, 2, 3, 4, 5, 6, 7. These are called 7-member variables. These are a ball class's member variables. So that's data that is represented by a variable like an int or a string, or in this case a boolean, to help control the direction. And then down here, notice now we have some methods. Def.show, this one should display the ball to the screen. So we have to definitely draw an ellipse, if I can spell it right. So our ellipse is located, this is where you have to refer to yourself, let's say at the x position, self.y, that's your center. And in this case, since we didn't have a size, the ball will just be 10 pixels by 10 pixels. All right, so far so good. We've defined some variables. We haven't used a lot of them yet. And then we defined one method, show. So now, down here, when we delete this ellipse, we should still see, well, where did we start it? At 50, 50. So in our canvas, that's 500 by 500. It should be in the upper left-hand corner of size 10 and 10. So this is the code that I added, lines 9 through 20. And at the very, one more thing. So and then we got to call your constructor. So ball, let's give it a name, Bob. And then you'll do bob.show. I should call it in the setup, like this. Is that what you're suggesting?
Yeah.
And we should, let's run and see what happens. It complains. Bob is not defined. So,
Aren't you supposed to define it clearly?
we can. Oops. Oh no. Oh no. All my changes. Oh good. Oh no. It's. Oh, darn. There goes all the code I just... Darn it. I hate this problem. I think it's happened to all of you too, right? Okay, so again, Bob equals... you should get a ball that displays the screen. I really hope so. Ball, and then bob.show. Okay. Code like the wind, Mr. Chan. Okay, what did I have here? Ellipse. Self.x, self.y, 10 and 10. So while I'm filling this in, maybe you can do the bounce method or have it move. What does it mean for a ball to move? You have to use your speed. This.x, self.x. Let's say 50, self.y equals 50. We're going to need speed. Self.speed. Let's just have that equals 10. Okay, I hope that's enough to get started. All right, now we click run. It complains ball is not defined on line this one. Oh, I called it building. Ball. Okay. Show takes 2 arguments. Fine. Go away. All right, so at this point, you should get a tiny little dot up on your upper left-hand corner. Yes? Yes? Hopefully, yeah, maybe.
Wait,
So that's why, there were 2 additional lines I added in draw. You must declare your ball. Yes, it will be declared a bunch of times, but that's okay for now. And then you have to call whatever you name your ball, call the show method, and that's using that dot operator. So lines 20 through 21 on my example, you need to add that in the draw to get something to display.
how do you make it not loop?
Don't have it. You'll work on that. So lastly, because there's only a couple minutes left with catastrophic going back on this thing, so you need a move function. And so you have to do it similarly, self, and then let's say we'll just leave it self.x equals self.x plus speed. We'll just have it move across the screen at the right plus self.speed. So notice how we define that function there. Notice you have to still refer to yourself. And based on your own x coordinate, you add your speed to that. Now when it repeats, when the new line of code is on 14, we should get something that moves. Is it moving? So you were right, Calvin, about declaring Bob at the very beginning. Bob equals ball, global Bob, bob.show. Ball is not defined on line 5. So we'll put it right here between your class definition and setup. Hopefully now it won't complain. Does it move ever so slightly? Ah, of course it doesn't, because we didn't tell Bob to move just yet. So now Bob moves and Bob shows. Whoops. Perhaps we don't want to draw it over and over again. But this is where we stop for now. As I save my code, I will share this on slide 3. There's only 2 minutes left to class, and that's why I have to pause now.